Event-driven architecture. Have you ever built a crucial system only to watch it slow down or crash completely because one tiny, unrelated service went offline? Welcome to the problem of synchronous, tightly coupled systems. Imagine an order process. The payment service immediately calls the inventory service, which then calls shipping. It's a waiting game. If the inventory service goes down or is slow, the payment service waits and eventually times out. The entire chain fails, and the customer sees an error. It's brittle because the services are directly dependent on each other's immediate availability. Event-driven architecture flips this by making components react to facts, called events. An event is simply a record of a change in state like payment successful. EDA relies on three parts. First, the producer. This service detects a state change and publishes the event. In our order flow, the payment service is the initial producer. Second, the event broker. This is the critical piece, typically a message queue like Kafka or RabbitMQ. It uses queues or topics to reliably store and route events. The queue is the crucial durable storage. It guarantees events won't be lost and maintains the order they arrived in, acting as the single source of truth for the event. Third, the subscribers or consumers. These services listen to the queue. Our inventory service, shipping service, and notification service are all subscribers, executing their specific logic only when they receive an event they care about. To execute this multi-step process, we use the saga pattern. A saga is a sequence of local transactions, all driven by events. Step 1. The payment service finishes, publishes payment successful, and is immediately done. Now, two things happen simultaneously. The inventory service consumes that event to start the fulfillment chain. In parallel, the notification service consumes the exact same event to immediately send the customer the order confirmed email. This is key. The customer gets their confirmation email instantly without having to wait for the stock to be reserved. This is instant responsiveness. Back to the saga. The inventory service finishes, commits the stock reservation, and publishes its own event. Stock reserved to the next queue. Finally, the shipping service consumes the stock reserved event to generate the label. This gives us the Monte Mando 1 benefit, loose coupling. The producer doesn't know or care who the consumers are. You can add a new loyalty service tomorrow, and the order service code doesn't change. Benefit number 2, scalability. You can scale your busiest consumers, say the inventory service, without scaling the others. The biggest architectural advantage is resilience. What happens if the inventory service consumes an event but keeps failing? Maybe the message is corrupted. The broker automatically redirects the failing message to a designated holding area, the dead letter queue, or DLQ, typically after a set number of retrieves. The DLQ isolates these poison pill events, allowing successful transactions to continue. It gives us time to debug the failure and safely reprocess the message later without losing any data. What if the process fails mid-saga? Say the payment service charges the customer, but the inventory service finds the item is permanently out of stock. The inventory service must trigger a compensating transaction. The inventory service publishes a new failure event. Stock reservation failed. The payment service then consumes that event and initiates an immediate refund. This undoes the previous step, ensuring eventual consistency and data integrity across the distributed system. EDA isn't a silver bullet. The biggest challenge is debugging. tracing an event across multiple queues and services is complex. You need good centralized logging and tracing tools. The final challenge is the shift in mindset required for eventual consistency. We accept that data might be momentarily inconsistent, which can impact user experience if not handled carefully. The takeaway: use event-driven architecture. When you need high scalability, real-time reactions, and maximum resilience for complex workflows like financial trading, large-scale e-commerce, and IoT data processing. I'm Ashish Kumar. Thanks for watching. That was our deep dive into event-driven architecture, the key to building loosely coupled, resilient, and highly scalable systems.